The goal of my presentation today is to go through a step-by-step the various settings required in the pulse generator, the online analysis, and the protocol editor, which will lead to a Patchmaster configuration that provides both a high-resolution acquisition and a lower-resolution chart recorder. I will be using the EPC10 USB to test the configuration with a model cell attached. Why chart recording? Well, there's many applications where monitoring is required. We can monitor capacitance measurements, to monitor fluorescence over time. Actually, this is part of Hubert's talk today. And this example, we're using it to monitor self-health. We're going to monitor the series resistance. We want it to remain as low as possible. And we will also monitor membrane capacitance. We want that to remain stable. Okay, with that, so I will jump into Patchmaster. So I'm using Patchmaster in its default configuration state. This is basically the way it would come out of the box, or in today's standards, downloaded from the website. So the first thing the Patchmaster always asks for is for the creation of a data file. Even though acquisition can be executed without a data file being opened, it's always a good idea to create the data file. You could always delete unwanted data, but if it wasn't stored, you can't retrieve anything. So with that, we'll create our data. Let's give it a name, test. So once a data file is created in the control window, the store button will also be enabled. This button basically allows you to enable or disable the storing to disk. For those who are new to Patchmaster, I'll give you a quick overview of the screens that we have here. We have our amplifier control window, our oscilloscope display. We have our replay window. This is where our data tree will be built and all our data will be stored in here. We have our online analysis window. This is the results of the plots that we're going to be generating. And finally, the control window. This is where we can execute all our pre-programmed pulse generator sequences as well as our protocol files. Before we get started, I'd like to make a couple of minor changes for the online analysis, as this is what we'll be looking to for our results. So first I will just make a couple minor changes, and I will also activate the second window because we'll be using that as well. Okay, now let's get started with the EPC10 control window. In addition to all of the hardware controls for the EPC10, we also have a built-in pulse generator as well as some user selectable buttons. These actually tie to the protocol editor. Usually Patchmaster will pre-program them with some default settings based on what amplifier is specified. And we will use these as we're preparing for our recording. As I mentioned earlier, we will be using the model cell for this, so let's get started with that. So first I'm going to put the model cell in the 10 megohm position. This circuit will basically simulate a 10 megohm pipette open to the bath solution. So here we go as our test pulse is running, and we'll run setup, which will basically execute. What it does is it will change the gain, set the recording mode, preset some settings for the amplifier, and then perform V0, an auto offset correction. If any correction is applied, it's added here to the V0 control. So it's 0.1 millivolts, quite small. Okay. Next, we're going to move the model cell to the middle position. This basically simulates the formation of a gigaseal with approximately 6 picofarad capacitance. As you can see, we have some fast capacitance transients in our current trace, and those could be neutralized by executing the seal button. And here we go. So you see all the fast capacitance have been neutralized. Finally, we'll put the model cell into the 0.5 gigohm position. This will simulate a model cell with the input resistance of approximately 5.1 megohms, a membrane resistance of 500 megohms, and a membrane capacitance of approximately 22 to 23 picofarads. We have here the slow capacitive transients. Those could also be neutralized by executing the whole cell button. And you can see determination did not complete, would not fully complete, so we could just execute it one more time to do that. Okay, we're almost ready to go into our recording. Next and final thing we need to do before we leave the amplifier window is to specify a holding potential. So we set it to -100, and now we're ready to start our recordings. Before we could do that, though, we need to generate a pulse generator file or a stimulation sequence. So we'll do that from the pulse generator. Okay. So Patchmaster includes a number of preset files for both the pulse generator for the online analysis and the protocol. Typically, I recommend that people use one of the pre-programmed sequences and just modify it for their needs. What I will do is I could actually start from scratch just so I can show everybody step by step. So first, we find an empty button in our pool, and we give it a name. So in this case, I'll call it IV Demo. Oops. Sorry. Name here, IV test. Okay, sorry. Okay, so we're starting off with basically a clean slate. So for this example, we're going to be basically creating a 3-segment sequence that will give us an IV relationship. So we start off basically where we have 3 segments. The first and the third segment are actually equal to the holding potential, so we need to set that. And our second segment here is where we're actually going to be doing the depolarization steps. So we'll start off with our initial value of -60 millivolts. And we want to increment each step by 10 millivolts. As you can see, this had no impact yet because we have to also make a change for the number of sweeps that we actually want to do. So we're going to be doing 9 depolarization steps. We enter 9 here. And here now in the sequence cartoon, you have a good representation of our stimulation pattern. One additional thing to make this accurate is that we need to specify what the holding potential that we are planning to use. So previously in our amplifier window, we specified -100 millivolts. So we enter that here. Now please keep this in mind that this is only for display purposes. It's only used to update the sequence cartoon. It has no interaction with the amplifier itself. Okay, so now that we have our stimulation sequence, we need to specify what channels we want to acquire. So we start up with some default settings. We're using the stim D to A output on the EPC10 amplifier, and it's actually also has a stim scaling applied. This is a value that needs to match the amplifier, and it's saved in the configuration file. For our input channels, we are going to be recording from current monitor 2, which is our filter 2 output, as well as our voltage monitor. So we'll add that as well. So here's our voltage monitor. Okay. Now, two more additional things that we can modify in the timing is the sample interval, the sampling rate of our acquisition. For this example, 50 microseconds will be fine. And also a sweep interval. So a sweep interval consists of the sweep length plus any additional delay that we want to add in between sweeps. So let's say we're going to put here 1 second. Okay, so now we have that. Now, finally, the pulse generator can be tied to an online analysis method. We haven't defined the method yet, but we do know that what is our relevant segment of interest. So we know that this is the segment here, segment number 2, that's going to be changing. So we're going to add that here. So basically this just defines a region of interest for the online analysis. Okay. Now, we could execute this stimulation sequence directly from the pulse generator or from the control window. So for now, I will close the pulse generator. As you can see, it was added to our control window, and we can now execute it from here. Okay, so unfortunately, I had specified some very large scaling factors before I started, and now so part of it started off the screen. So we could easily just reset for trace 1 and then for trace 2. And now we can modify our display the way we would like. So typically what I like to do is I like to use the keyboard to do that, which basically will allow us to adjust the scaling factor and the offset factor. So first we specify the channel or the trace that we want to work with, and then I will use the shift minus or plus key to move up. Here we go, and we'll also scale our current trace a little bit, and then we'll do the same for our voltage trace. Okay, and now we could actually do one more test just to make sure we could see what we want on the display. All right, so here we go. Here's our voltage, our steps, and our response, our current response. Okay, now we can go into the chart recording or the online analysis. So for that, we open up the online analysis window. Again, there's already some pre-programmed methods already in, but we'll start from scratch. So what we'll do is we'll find a blank button as well. Now we'll do this IV test. And we will not copy anything. We'll start from scratch. Okay. So to design our online analysis, we first have to define the functions, and then we have to create a graph, what X versus what Y. So first let's start off with our functions. So click to get our function list, and we have, as you can see, quite a number of different functions to choose from. Since we're looking for a current to voltage relationship, we're going to first get our current, which is mean. We have a default name, which we could actually change. And also we could tell Patchmaster where to get the data, where to compute this data. So either we go to the relevant segment, which we specified in the PGF, or we could set the cursors relevant to the whole trace, beginning to end, and then modify the cursors. So we'll do that segment, and done. So that is our first function. With this function, we could specify cursor bounds, again, another to minimize the region where we want to calculate this data. We could also tell it what channel we want to get the data from, and we could also add this value to the notebook. So as the online analysis is being computed, this value could also be added to the notebook for bookkeeping purposes. So let's add another function. This time we're going to add our amplitude. So we have our current function and our voltage. So now we go and we specify our graph. So here we will enable our graph, here and here, and then we specify here. All right, so here we have our graph, what X versus what Y. Now we go in and we want to modify the axes. So the easiest thing is to specify an order series axis. What this will do is, after all of the sweeps in a particular series have been acquired, it will take a min-max of these values and then compute the axes automatically. But this means that the plot here will not occur till after the acquisition has terminated. In this case, we're doing more of a chart recorder style, so we want actually to use a scaling where it's actually computed after each sweep. So what happens here is that after each data point is computed, the axes will be drawn based on that one point, and then with each new point, the axes will be recomputed and redrawn. And we'll just set overlay to make sure that we're not clearing out any of the old data points. Okay, so And finally, we need to say, okay, this graph, what position do we want it? We have two windows we could choose from. So here I will disable any graphs from previous online analysis, and I will say that I want this on online window number 1, and that's where it will be drawn. All right, so that is our first online analysis. We want to, now here, this control will tell us how this method will actually be executed. No online analysis means that nothing will occur when we do an acquisition or playing back of the data. We could have use selected method, which basically forces this method to be executed for any new acquisition or any replaying of data, or automatic stimulus control. Now, automatic stimulus control is what ties it back to the PGF. So do that, and let me go back to the pulse generator. And here in the pulse generator, where we specify what analysis method we want to run. So here we have IV test, and we close that. Now, when we execute IV test, as you could see, the traces are the current trace and the voltage trace is there, and our data points are also shown in the online window. Okay, now let's try to expand this some more. And by the way, I just noticed that I did make one mistake with this. I should have mentioned that it was for trace number 2. Sorry about that. So now we're going to add a few more functions to our online analysis. So go back to our function, and we're going to get timer time. This is the Patchmaster acquisition timer that's specified in the control window. It could be reset from the control window. We'll add another one called, these are now trace parameters. So we can go our series resistance. And finally, membrane capacitance or C-slope. Again, it's another trace parameter. Okay, so now we have a few more functions that we could graph. So we'll go back up to our analysis graphs. We'll create a second graph. We'll enable it. So, and let's go here and put in what we want, what our X and Y is going to be. So we'll go with timer and our series for one of our graphs. And we'll enable a third graph. This one will be timer and C-slow. And now, again, same thing. We have to specify the scaling of the axes. Again, I'm going to use after each sweep for graph 1 and for this one as well. Okay, and finally, we need to put what positions they're going to be drawn in the graph. So this time, we're going to use online window number 2. So here we'll put graph 2 in position number 2 and graph 3 here as well. So now we have an online method called IV test that has 3 graphs. One, the IV on window number 1, and then R series and C-slow in window number 2. So we could execute that as well. Okay, now let me close this window, make this a little easier to see. Now, so this was during an acquisition, but if we quickly wanted to go and actually replay back any of our acquired data, we could just go here to our replay tree, find the series that we're interested in, and double click on it, and that will give us our results for that acquisition as well. Okay. Now, this is a good time to introduce the protocol editor. So with the protocol editor, basically will allow us to generate a sequence of experimental events. It's a programming style language. We have all sorts of loop capabilities like repeat. We have all sorts of conditioning statements built in, but we're going to start with a simple one where we're just going to repeat one of our series 5 times. So we'll go and find again a blank. And we will not copy. Okay, so first what we do, and here we have where we can specify what commands are available, or what events are available, I should say. And we'll start off first with a repeat. And here with repeat, we can specify the counts, 5. Then insert after is we are going to acquire a series or one of our stimulation sequences. And we could select it from the PGF pool. And here's a list of all the available pulse generator sequences in our file. IV test. So here now we have a very simple repeat loop. It will do. It will just acquire this sequence IV test 5 times. So I'll move this out of the way. And again, now you see back in the control window, this new protocol has been added as well. Execute it. And actually what I'll do is I will try to flip through the model cell here to try to get some additional data points stored in here. Okay, now with R series and C slow, since they are trace parameters, they're usually updated every time an auto C slow is executed on the EPC10 amplifier. So we could add that now to our protocol editor. So here we go back, and right before this execution of this series, we're going to add what we call an amplifier control. Okay, so now we're going to execute an automatic C slow that before it executes each of the acquisition series. So execute that. Okay, so basically these were the basic steps for getting a chart-style recording configured in Patchmaster. I mean, the protocol editor could be expanded even more. We could add the execution of or additional PGF templates or additional sequences and other online analysis that will keep these basically this monitoring of either the series resistance or C slow or any other parameter ongoing over any length of time. But that will be, I think, for our next webinar. So with that, I'd like to thank everyone for listening. And let me switch over. Sorry. And let people know that there are pre-configured tutorials on our website. Basically, they have all the files for the configuration, for the online analysis, and for the PGF for a variety of different tutorials. We have a chart recording with Patchmaster. It's more enhanced than what I've shown. Capacitance measurements, fluorescent measurements, and also using a recorded waveform of stimulus. If you have any questions, please feel free to contact me at ussales@heka.com, or you can call me, or always our support line is always available. Thank you.